Hi, welcome back. Differentiation. Basics of differentiation, part 2. Basics of differentiation. Let's look at this function log x. When you differentiate log x with respect to x, you will get 1 over x, 1 over x. And also, instead of log x, we replace x with a function of x, fx. Then differentiate log fx with respect to x. You get 1 over fx times f dash x. This is the function that you get here. It will be 1 over fx times the differential of that function. Here we need to know that the function fx is a differentiable function with respect to x. Okay, let's see a few more. Here we have ax, differentiation of ax with respect to x. You get ax times log a. So ax times log a, e to the power x. And if you differentiate e to the power x, you still get the same thing, ex. Differential of ex with respect to x will be ex. Also, instead of x, if you substitute with the function fx, then differential of d over dx e to the power fx will become e to the power fx times f dash x. Again, f dash x is the differential of fx. Here also we need to know that fx should be a differentiable function. Okay, let's see an example here. D over dx e to the power x squared. Here x squared is like fx, the function of x, and the answer to this one is e to the power fx, means e to the power x squared times f dash x. If you differentiate x squared, you get 2x. So answer is e to the power x squared times 2x. 2x is like f dash x. Okay, let's continue with few more functions. So here d over dx cu, c is a constant, u is a function of x. So you get c out here times u differentiate with respect to x du by dx. So instead of c, if you substitute it with the function of u, function of x again, so u times v, both are functions of x, and then you get u dv by dx plus v du by dx. This is a differential of a product. U and v are both functions of x. And instead of u and v, we can have three functions. Then that is u v w, d over dx, u v w, all are functions of x. Then take two together, always u v, the third one dw over dx plus vw du over dx plus uw dv over dx. And if it is division of two functions u over v, d over dx, u over v, then you can write it as, first take the denominator v du by dx, denominator times du over dx, minus numerator times dv by dx, divide by v squared. Okay, this is another function here, d over dx u to the power n. U is a function of x, so you can write n u n minus 1 times du over dx. This is very similar to the one that we saw earlier, d over dx x to the power n is equal to n x n minus 1, but in this case x, if you differentiate with respect to x, it is 1, but here it's u. When you differentiate u with respect to x, it will become du over dx. And also the chain rule, dy by dx can be written as dy by du times du by dx. Basically du and du are common, so then you get dy by dx. Also you can write dy by dx equal to dy by du divided by dx by du. or it can be written as 1 over dx by dy. Okay, let's see inverse trigonometric functions here. D over dx sine inverse x equal to 1 over square root of 1 minus x squared for x between -1 to +1. Similarly, cos inverse x differentiate with respect to x will become negative of 1 over 1 root of 1 minus x squared for x -1 to +1. Tan inverse x can be written as 1 over x plus squared, x plus 1 over 1 plus x squared, and cot inverse x equal to negative of 1 over 1 plus x squared. Also, sec inverse x or secant inverse x is equal to 1 over modulus of x times root x squared minus 1. That is for modulus x greater than 1. Similarly, cosecant x can be written as negative 1 over modulus of x times root x squared minus 1 for x greater than 1. Okay, let's see an example here. Find dy by dx when x and y satisfy this equation. 2x to the power 4 plus 3x squared plus y4 plus xy equal to 40x cubed times y squared. So to do this, what we need to do is we differentiate left hand side and right hand side with respect to x. So when you differentiate both sides, first left hand side, so if you differentiate left hand side, 2x power 4 become 8x3. Basically 4 will come here and 4 minus 1 n minus 1 plus 6x2 minus 1 6x plus 4y3 times dy by dx, because y is a function of x, plus this is a product here, x times dy by dx plus y times dx by dx equal to 1. So this is like uv. We saw earlier when you have a product, u dv by dx plus v du by dx. This is the left hand side. Similarly, we can write an equation for right hand side. That means if we differentiate the right hand side, 40 x cubed y squared, 40 x cubed, again this is a product here, x cubed times y squared. If you differentiate y squared, it will become 2y dy by dx plus differentiate x cubed, it will become 3x squared times y squared. Basically it's y squared du by dv by dx equal to 3x squared. This is the right hand side. We can equate the left hand side and right hand side. So then we get this expression. This is the left hand side, this is the right hand side we just now obtained. And then we take the terms with dy by dx into one side and the terms without dy by dx into another side, the other side, and then take this term to the denominator. Then we'll end up with the answer to dy by dx. So dy by dx equal to basically 120. This side will be the numerator and this term will be the denominator. So basically what we did here was just collected the terms with dy by dx into one side and send the other side, and we got an expression for dy by dx.